AirUCI is a collaboration between 18 scientists and engineers who study various aspects of air pollution. Although ozone is a very toxic air pollutant, particles are also known to be very toxic. They have known cardiopulmonary effects, and they have been shown to have increased mortality. And in fact, atmospheric models tend to underestimate them significantly, sometimes by as much as an order of magnitude. The goal of our studies is to understand why there's a discrepancy and if we can help resolve that discrepancy. We use a very sophisticated aerosol flow tube that you can see behind me here, and you'll actually see the formation of these particles from the reaction of ozone with alpha pinene.
We're going to demonstrate that here using water vapor droplets and a LED laser using this long path FTIR cell. It's designed so that by increasing the path length of light through a gas phase sample, you can really get a stronger signal from any interaction that the particles or gas phase species have with that light. Measuring the way that light interacts with particles and gas phase species is very useful for measuring not just their concentration but also physical properties, including composition of particles or the gas phase.
Our research showed that at least in some systems, those low volatility gases go into the particle, but they don't come back out. What this means is that you're going to get more massive particles in air faster than current models predict. This is very important because particles do have these negative health effects, and so predicting how we're going to control them really relies on the atmospheric models saying if you start out with this much precursor, you're going to get this much particle. In the future, we're going to be looking at more complex systems to see whether what we've observed is in fact a general phenomenon. And what we hope will come from this is a general approach to how you predict particle formation in air, and in such a way that it can be introduced into models in a fairly straightforward manner. We really need to understand quantitatively that connection.